Welcome back to the second part of this series that's looking at integration. So in this video in particular, we're going to look at the integration of power functions, which are very similar to polynomial functions, except now we can have negative powers and fractional powers. That's the examples we're going to look at. And we still follow the same rule as part one, which is written up there. So in this video, we're going to see again an example of an indefinite integral. And then we're actually going to find a unique solution. So we're going to find a value for this plus c, and we can do that when we're given extra information like we are in part two. So first of all, if we look at part one, we want the integral, or the antiderivative it could be called, of 3 divided by x squared plus 5 divided by the square root of x. We want to integrate that with respect to x. So the first thing I'm going to do is I'm just going to rewrite this integral so that we can reveal what the real power is of x in this form. So instead of having 3 over x squared, we're going to write this as 3 multiplied by x to the power of negative 2. And then instead of having 5 divided by the square root of x, we're going to add on 5 times x to the negative 1/2. That's equivalent to 1 divided by the square root of x. And we're still going to integrate that with respect to x. I'll just put brackets back in there because we're going to do that to all terms. And now we just apply this rule. So this is going to equal, and the rule says that we essentially add 1 to the power and then divide by the new power, or multiply by its reciprocal. So here we're going to have 3x, and just be careful when you add to the power when it's negative. That's actually going to become negative 1, and then we divide by that new power of negative 1. And then we're going to add on to that. And here we have 5x to the power of negative 1/2. So that's going to be 5 times x. And we're going to add 1 to the negative 1/2, which will give positive 1/2. And then we need to divide by 1/2. But instead of dividing by 1/2, I like to think about multiplying by the reciprocal. So the reciprocal of 1/2 is 2 over 1. And then because we've performed anti-differentiation, we need to have that plus c, which is the constant that's part of that formula. So here it's just a matter of cleaning up a little bit. 3x to the power of negative 1 divided by negative 1 can just be written as negative 3. And instead of having x to the power of negative 1, you could write that as 3 over x. And then here we're going to have plus 2 times 5 is 10. So we're going to have plus 10. And x to the power of 1/2 is the same as the square root of x if you wanted to write it like that. And then of course we still have this plus c value. So that's the answer to part one of this question. For part two, instead of ending up with a plus c in our final answer, we're going to be able to find a unique solution. We're going to actually be able to find a value for that. So let's look at what we're given. We have f dashed of x is equal to the square root of x minus 3. And we're told that if f of 9 is equal to negative 4, we're asked to find f of x. So if we're given the derivative, we can find the original f of x using anti-differentiation or integration. So to start off with, we would say that f of x, which is what we're asked to find, is equal to the integral of the derivative. And it has a rule, the square root of x, which I can write as x to the power of 1/2 minus 3 dx. So therefore, f of x is going to equal, and we're going to add 1 to this power, so it's going to become 3 over 2. So let's write that down. We're going to have x to the power of 3 over 2. And again, we divide by the power, or what's slightly easier to think about is probably to multiply by the reciprocal, which is multiplying by 2 over 3. And then this minus 3 becomes minus 3x when we anti-differentiate that. And then we would have a plus c value here. But we're going to now use this next piece of information to actually find that c value. So we know that f of 9 is equal to minus 4. So let's go ahead and put 9 into this. So we're going to have 2 over 3, so I'll leave that there for the time being, multiplied by 9, and then that's to the power of 3 on 2. So I'm going to do the power of 1/2 first, and then cube that value. And we're going to discuss what that'll turn into in the next step. Then we'd have minus 3 times 9, and then plus c is equal to minus 4. So therefore, our next line would say that we have 2 over 3 times, and 9 to the power of a half is the same as the square root of 9, which just gives 3. And then we would cube that to get 27, but we also have a divide by 3 here. So hopefully if you're following along, we have 27 divided by 3, which will just leave 9, times this 2. So 9 times 2 is 18. And then minus 3 times 9 is going to give minus 27, plus some value c is equal to minus 4. So therefore we can work out what c is equal to. And this would be minus 9 plus something gives minus 4. So c must equal positive 5. So for our last step, we can say that the unique rule of f of x is going to equal, and we can start at this line here. We're going to have 2x to the power of 3 over 2 divided by 3. And then we're going to have minus 3x plus c, but c was 5, so we write that here. So that is our unique solution for part 2. So hopefully this has helped. If you want to see more examples of questions like this, click on the links below or that are in the description. And make sure you have a look at part 3, which is going to look at integration of functions that are in the form ax plus b to the power of n.